Welcome to the continuation of our series on reflection of light on curved mirrors. We are going to look at parts of the curved mirror. The first part we will talk about is the pole of the mirror. The pole is the center of the mirror. The pole is the center of the mirror. It is usually denoted as P. The center of the mirror is called the pole. The second one we are going to look at is the aperture. The aperture is the thickness or width of the mirror. How thick the mirror is its aperture. The third one is the center of curvature. The center of curvature. Remember, the mirror is cut out from a sphere. So the center of the sphere of which the mirror is part of, the center of the sphere of which the spherical mirrors are part of, is called the center of curvature. It is represented as C. The next one is the radius of curvature. Radius of curvature is the radius of the mirror, or you say the distance from the center of curvature to the pole of the mirror. So this is the radius of curvature. The radius of the sphere of which the mirror is part of. The radius of the sphere of which the mirror is part of, or you say the distance from the center of curvature to the pole of the mirror, is the radius of curvature. The next one is the principal axis. The principal axis is a horizontal line that runs from the center of curvature to the pole of the mirror. The horizontal line that runs from the center of curvature to the pole of the mirror. Why I'm not using here is because I have used this side to illustrate the radius of curvature. So I will put my P here. So the horizontal line that runs from the center of curvature to the pole of through the pole of the mirror is called the principal axis. Principal focus. Principal focus is that point on the principal axis where parallel and close rays to the principal axis appear to either converge or diverge after reflection. This is a point on the principal axis where parallel and close rays, so let me use concave converging as an instance. If you have parallel rays that are close to the principal axis, they will appear to converge here after reflection. So here becomes our principal focus. So principal focus is the point on the principal axis where parallel and close rays to the principal axis appears to converge for concave mirror after reflection, or appears to diverge after reflection for convex mirrors. Then the next is focal length. Focal length is the distance from the principal focus to the pole of the mirror. So this is the focal length. The distance from the principal focus to the pole of the mirror is called the focal length. It is important to note that center of curvature C, it is important to note that radius of curvature R, or small r, is twice the focal length. The radius of curvature R is 2 times the focal length. So if you have the focal length 10 here, from the principal focus to the center of curvature is also F. So radius of curvature is twice the focal length. In our next video, we will be solving problems involving mirrors and mirror formula.